That is a problem. Okay. See what's going to work today. See if you guys work. So it says Fred and Jim are in a race. Fred travels 2 miles an hour faster than Jim. How long until they are 10 miles apart? So, you got too many unknowns the way that I've set that up. So you have the speeds you don't know and the times you don't know. So that's impossible. Now that I think of it, yeah, okay, I got it. So if I give you their speeds, let's see. We got Fred and Jim. Distance equals rate times time. And again, this is 8c. Here it is. 7c, sorry. So let's say this. Fred and Jim in a race. Let me give them specific speeds. So let's say that instead of, so let's say Fred runs at 2 miles an hour and Jim runs at 4 miles an hour. Let's see how this works. Okay, maybe. So again, when you look at that problem, I'm not going to do this to you. This is more evil than I wanted to be, but I just had an idea of a problem and I just didn't pay attention that I didn't give you enough information. I had the answer in my head and I realized later that, holy shit, I left too many things unknown. So now I can't even remember what the answer was supposed to be. I didn't know distance, I didn't know how fast they're going, and I didn't know how much time. That's too many unknown things. So now I'm going to give you their speeds. So Fred's going 2 miles an hour, Jim's going 4 miles an hour. Now here's the thing. Now here's the neat thing. I think this is where I went off track because I didn't know if I wanted to be like this. They're in a race, which means when do they start? Does one start before the other one? They start at the same time. And then I'm going to watch them until they get to a point where they are 10 miles apart. So has either one of them been running for more time than the other? This is the one time you're allowed to use the same variable for both because you know they're both the same. However long Fred's been traveling, Jim's been traveling for that long too. Does that make sense? Not too many of you guys, a couple of you guys were using X's for every unknown in a problem, and that you can't do that unless you know they are the same. Okay, maybe. And which means, how far did Fred go?
2x.
2x, exactly. And how far did Jim go?
4x.
And I want their distances to be 10 miles apart. I want them to be 10 miles apart. Which means, what am I doing to these two distances? If they're 10 miles apart, what does it mean about one distance versus the other one? All right, let me see. So here's Fred, good old Fred. Here's Jim, right? Jim's running faster, so Fred's going to run, Jim's going to run a little bit more. Where's the 10 in this picture? This much, right? The difference. And I just gave it away. 10 miles apart means you want the distances to have a difference of 10. Say again? No. Let me say this again. So if you want to wait until they are 10 miles apart, that means you want the difference in their distances to be 10. I basically just said the equation in English.
4x minus 2x.
Yes. 4x minus 2x equals 10.
Yeah.
Coolness. And then that's a beautiful equation to solve. I love this problem because most of the time you're adding stuff to make something, or you're setting them equal to each other. Very infrequently do you see you subtracting them, but that's this problem. It's just, how do the distance relate? Are they the same? Obviously not. One of them is faster. Do they add to be something? No, they're going the same direction. So they actually subtract to be something. And then that's a very simple equation to solve.
They're 5 miles apart.
Say again?
They're 5 miles apart.
So yeah, you get 2x equals 10. X is 5. What does x represent? Time. So how long were they both going? 5 hours.
Oh, okay.
Done. So 5 hours later, they'll be 10 miles apart and very tired.
Oh, and then you could replace the 5 and figure out their distance if you need.
If you wanted to, but I didn't ask for that. Yeah. Now let's see. At 5 hours, how far did Fred go?
10 miles.
10 miles. 20 miles, and that's 10-mile difference. I love it. So the piece that wasn't on your practice test that I just gave you was this piece. I had to tell you something else. I had 2 unknowns. You can only work with 1 unknown. Yes?
I don't understand the 4x.
Do you understand the 2x?
4.
But do you understand the 2x?
The 2x, yeah, 4. It's very.
You okay with the 2x?
Yes.
Okay, so you have to understand the 4x. Where'd the 2x come from? Rate times time. So where'd the 4x come from? Rate times time. Distance is rate times time. So we got to a point here, right? I told you 4 and 2. And then we talked about the fact that they ran for the same amount of time. Yes? Okay, you said you had a problem with 4x, so you're okay with this, right? Or your question should have been about this. All right, so let's come all the way back. All right. Does everybody understand? This is new information I'm giving you right now. You can write this as part of the problem, right? Okay. So I can write in there, Fred's going 2 miles an hour, Jim's going 4. There's no question. Right? Let me try this again. So this is not on your paper, but it should have been. So where it says, Fred travels 2 miles an hour faster than Jim, cross through that and put this instead. Fred's going 2 miles an hour, Jim's going 4 miles an hour. I like it. I like it. Yes?
Quick question.
Yes.
Because it's a race, we're assuming they're going they went at the same time.
Yes.
Is that the reason? Okay.
Yes.
For the exercise.
It would have been really mean or weird if they would have let somebody go first. If it's a race, right?
But they could go like a 10, what is it, Jim went 0.5 seconds faster than.
But did I say that?
No.
All right.
Just said-
Faster than
All right, were you with me? So the whole second sentence is gone because I made too many things unknown. The time was unknown, and I also made the speeds unknown. That was my fault. I'm letting the speeds be known. Then, like Curtis and I were just talking about, it's a race, so they both start at the same time, and I let them run until they are 10 miles apart. So neither one ran more than the other one. They both ran for some amount of time, the same amount of time. The minute you get 1 box left, you just do what the equation says, right? Distance equals rate times time. Bam. Distance equals rate times time. Bam. And then I want to let them get to a point where they are 10 miles apart. So that distance minus the other guy's distance, I want that to be 10, a difference of 10. Way off, 10 miles ahead. I'm like, you must as well just call it. Shit, let these people stop. Okay, maybe. But Jim might take a nap. Fred can catch up. All right, I'm with you.
14 minutes per mile. Running 14 minutes for, what is it, running a 14-minute 2 mile.
Are you trying to figure out how long
It'd be
a mile run is?
It'd be 7 minutes for each, if you did 14 minutes. You ran all for 2 miles, and in the time you ran, it took you 14 minutes to run 2 miles. That's what I think.
All right, I'm not sure what that is. That's okay.
It's a
All right, so that's the one I definitely wanted to do with you guys, since I didn't give you enough information for it. Do not assume I'm going to do that to you on the test. I'm going to give you all the information you need for the test. That one I just kind of changed at the last minute to make it more interesting, and then I made it a little too interesting. So anything else you want to go to? You want to do another problem like that? You want to do something else from the practice test? You got questions from homework? You got questions from the quiz? From the other quiz, both quizzes are due tomorrow for corrections. If you want as many points back as you can. You can always give me stuff late. So the later it is, the less you get. Should kind of make sense.
Can we do, what is it, a word problem with money? Like,
Sure, yeah. Some people are bringing in, so bring out what they want from this, more than you wanted. All right. So let's say I had, I don't know what kind of problem you're thinking about, but like a quarters and pennies problem or something?
dollars,
Or-
quarters, what?
Yeah, okay. So say I had, what you got, Jeff? Oh, I don't know. Scheisse. Let's say I had, don't make it too crazy. Yeah. I got $2.50 in nickels and quarters. I have, shit, I just forgot. Yeah. 18 coins total. So how many nickels and how many quarters do I have? Too much writing. So when you first read through that, there's a lot going on, but you have got to focus on one thing at a time. The first step has nothing to do with math. Screw the math. First step. Don't generally screw the math. So what's my first step? What do I write down? What is it that I don't know?
Nickels and quarters.
The number of quarters and the number of nickels, right? What I've, say again?
5, 25.
No.
What?
It's so weird that you said. What I just wrote down has nothing to do with money. Has nothing to do with an actual money amount. Do you see that? The number of nickels, the number of quarters. I didn't say anything about the amount of money.
0.05x.
No, still, no money. No money. So what are you going to call, it doesn't really matter which one you call X. So if I call this one X and there's 18 total, how many quarters do I have? So if I had 2 nickels, how many quarters do I have? 16. How did she know that? Because I got a total of 18. If I had 5 nickels, how many quarters would I have?
18
If I have 18 coins, nickels and quarters, 5 of them are nickels. How many quarters do I have? 13. If I have 7 nickels, how many quarters do I have? 11. What do you keep doing? 18 minus whatever the hell I say.
Oh.
So if I have X nickels, how many quarters do I have? 18 minus whatever the hell I just said. And remember, I told you, you can always do that. You can always give yourself a value that makes sense here and see what your brain does to it, because your brain latches onto numbers. When I put a variable down, my brain's like, I don't know. It's like a Lego that don't fit. Duplex and a label, a Lego thing. No, it's not going to work. Does everybody see how this makes sense? This represents, if I have 18 total, 2 here, 18 minus 2, 16 there. Now you bring money in. Right? The things I don't know was the number of each coin. That has nothing to do with how much they're worth. Right? So some people are trying to sneak in here, and that was throwing you off, trying to sneak in your money. No, now I bring money in. What do I get from all the nickels?
5 cents.
5 cents. So if you want to make this in terms of cents, I just got to be careful here. So this will work beautifully if you don't like decimals. If I get 5 cents per nickel, is that cool? 5 cents times the number of nickels is how much money those nickels gave me, right? Plus, how much for each of these?
25.
25 cents for each of those. It's equal to how many total cents? 250. So I love it. You can make things into cents, but you better make everything in terms of cents. If you put this, you somehow have 2.5 cents. No, right? We're not England. We don't have half pennies. Huh? Tuppence. Tuppence a bag? No. Feed them birds. If you did this in terms of dollars, this would have to be 0.05, 0.25, 2.50. You don't have to do that. As long as all the units match, you're golden. So my point is, you guys know that the unknowns are how many. So there shouldn't be any 5 or 25 in here at all. It's just about the number of coins. When you set up the equation, you bring in the amount of money you get. So watch this. So the rest of this is almost anticlimactic here. 5x plus, what's 18 times that? 450? Maybe? Let's just pretend like it is. I normally know. You never know. I could be wrong. Subtract 450, divide by -20, get in there. I get 10. 10 what?
Nickels.
10 nickels. And then how many quarters? 8 quarters. Blah, blah, blah. I don't care. Now watch this. Let's see. I don't know what you guys are going to think about this. Apparently I don't care. I'm going to put it up here. Let's see what happens. So watch this. What if I have an entirely different problem? 18 people come to a concert. Right? And the band normally gets 3 people show up, so they're excited. We make $250 total. Some were adults. Holy crap, Jeff. Let's say some were students, and some were just regular old adults. Otherwise, I don't know how the hell to say that. Right, so students get a discount. I think I should get a discount for every student I have, but I don't get any discount. Screw you, teacher. All right, fine. Is everybody with me so far? 18 people made up of students and not students. He went to a concert. The student tickets were cost, let's say, just to make something up. Yeah, cost $5, and the non-students cost $25. That's a discount. That's a discount. So, what is it that's not known? What am I going to ask you? I didn't really ask you a question yet. How many of each came?
18.
What the hell are you guys talking about? How many of each? Oh. So what are there? What's 2 different kinds of people?
10 students and 8.
Yeah, you got it. But just sit on that for a minute. What kind of students do I have? How many of each came? So I have students. What kind of people do I have? Students, and I have not students, right?
Yes.
Is that cool? Right, I want to know how many of each kind came. So the number of students and the number of not students, right? So if I don't know what either one is, but if I call this X, and there are 18 total, how many not students came?
X minus X.
18 minus X, right?
Yes.
Again, whenever you have a total amount and one part is X, the other one's going to be total minus X. You actually know that. You're just not used to thinking of it that way. If there were 30 people and 11 of them are left-handed, how many are not left-handed? 30 minus 11, right? So it's always total minus the amount you set aside. So X here, this is going to be 18 minus X. Now, like you realized, how much money did I make off each student? How much money did I make off each student?
$5.
5x. How much money did I make off of all the other ones, suckers?
25.
25x. 25, no, not x, but 18 minus x, right?
Yeah.
25 for each of them, 5 for each of them, and all together I made $250. That situation came out to be the same equation. That's fine. Of course it did. I kind of like that. I don't know if that did anything for you. Wouldn't you say that these situations are very different? Of course you would. But we actually have an equation that models both. So yeah, you're right. The answer will be 10, what was it?
Student.
Students, yes. 10 students and 8 not students. All right, enough of that. Okay, anything else you guys want to look at? I kind of like that. I don't know if you guys care about that one way or the other. But any equation could actually represent multiple situations. It's fine. I can have 8 nickels and 10 quarters. I can have 8 students and, or the other way around, whatever the hell. Right? Of course I can. All right. Anything else? Quizzes, homework, general questions. We can do another distance rate time problem. We can do percentage problem. We can do anything. It's up to you guys.
Distance over time.
What do you mean distance over time? Or you mean just that kind of problem?
Yeah.
So, was there a problem in the book about like half an hour or something? Maybe? No? So let's say I leave at 2 p.m. traveling 60 mile an hour. You leave at 2:30 p.m. traveling 80 mile an hour. How long until you catch up to me? So I leave your house and I left something there. Must be my phone, or else you just call me and say, hey, you left this shit here. So I leave my phone there, and you're like, I don't want this person's phone. So you take off after me, right? You're like, I know Jeff goes 60, so I'm just going to go 80. I'm going to catch up someday. You guys with the idea of this?
Traveling what?
Say again?
Traveling what?
Traveling 80 mile an hour?
No, 60?
Traveling 60 mile an hour? Yeah, okay. So what is it that we don't know? What is it that we don't know?
How long are traveling to they be?
How long who's traveling?
I
It might be better to, let me make this better. Let's say Jeff and Curtis. All right. Because the IU gets weird when I'm asking. So what is it that we don't know?
How long Curtis is traveling?
Good. How long Curtis? Until Curtis catches up with me. Right? You guys with me?
Yeah.
All right. So X, so let's see. So what do we got? What are the two parts? What are the two players here? What am I going to put here? Obviously it's going to be
Jeff
me
and then Curtis.
and Curtis. Right? And what goes up here?
Distance, rate, and then time.
I like it. What do we know for sure? No question. We just know it. There's no unknowns.
The time.
I just know it. No.
The rate.
Oh, the rate, yeah.
Time is exactly what I don't know. The rate, yeah, I'm going 60 and you're of course going 80, so you have a chance of catching up to me, right?
Yep.
Now, Curtis, you just told me that's what we don't know. How long Curtis has been traveling. So let me put an X right here. Who's traveling longer, me or Curtis?
You.
Jeff, right? Me. So if Curtis is traveling for X hours, how much longer have I been traveling?
30 minutes.
30 minutes, which is how many hours?
0.5.
Good. So don't put x plus 30 here. That's going to freak the equation out. You can't have hours and minutes trying to work together. It freaks the hell out. So I've been traveling for 0.5 longer. Do you guys, let me stop for a minute. You write down definitely what you got to just be given something, right? Which is a mistake I made on that problem on the practice. I didn't give you anything. I was feeling extra evil. And then you've got something you don't know, but you know how it relates to the other part. Right? So I don't know how long Curtis has been traveling, but I know I've been traveling for half an hour longer than that because I've been on the road longer, right? And now what can you do?
One,
Go home and hope there's not too many word problems? No, stop.
you
What-
combine the
Yeah, what goes here?
80x.
80x. I know distance is rate times time. What goes here?
60.
60 times,
X plus 0.5.
Yes.
right? Just multiply those together. Because that's the equation, right? If I know the rate and the time, I multiply them to get distance. Bam. Now here's the neat part. Who can see what the relationship is here between the distances?
20 miles per hour apart.
No. This is distance, not velocity. Think about it. I leave wherever the hell we are, right? I leave. I'm gone. He's going to try to catch up to me. When he catches me, has either of us gone longer distance? We've gone the same distance, right? He's trying to catch me. So what am I going to do with these two expressions? Based on what we just said, the two distances have to be equal. That's so freaking important. What's important is what is x? Everything builds off of that. In this problem, it's how do the last two things relate to each other? The distances here have to equal each other, or else he didn't catch me.
Yes.
If his distance doesn't equal mine, he hasn't caught me yet. Or he shot past me. What good is that? I want that my distance has to equal his distance. That means he caught me. Why are you on, poor little dude? I cannot self-terminate. Okay, sorry. And then, let's see if Jeff made a problem that makes sense here. 60 times x, I'll do that for 60x. What's 60 times a half?
30.
30. This comes out not too pretty, but oh well, too bad. Huh, doesn't come out bad. Is that cool, right? And then divide by 20. So I think, and this is understandable, you've got to let go of where you were to get to where you are. You got to work with where you are. I understand right now you might be trying to figure this out, which means you should have asked the question about a minute ago. If you didn't ask a question, let it go, or ask it now. But now we have this equation, I'm just going to focus on the equation. I'm not going to worry about where it came from. If I trust where the equation is right, I start working with it. And then I have to divide by 20. And what's 30 divided by 20?
10.
Doesn't come out perfect.
No.
That's 3 halves, right? 3 divided by 2 is?
1.5.
So 1.5 hours later, he catches up with me. What time would that be?
That'd be before, yeah.
4 o'clock. An hour and a half past when he left, right? So 4 o'clock. Maybe. That's a question I could ask you. Depends on how I'm feeling when I make the test. Okay, maybe. So real quick before, do not get too wrapped up in the specifics of any problem. You have got to get down, what is it that made me fill these in the way I did? What is it that I know? Put them in. What is it that I don't know related to the question? Put those in. One of them is going to be X, the other one could be something else, unless they're equal to each other, right? So I put X there because it's Curtis, and then I got to figure out, well, how's mine related to it? Half an hour more. I've been on the road since 2. And the minute you've got 2 of these boxes filled in, you can fill in the last one using the equation. Now I could have said, how long until Curtis is 10 miles away from me? And then it would have been this minus this equals 10. Or I could have said, how long until together we've gone 400 miles? And then it would have been this plus this equals 400. You guys, we've done problems like that. But in this case, he caught me, which means we went the same distance. So that's what the equation is made out of, is how do these things relate to each other? Okay. All right. You want to leave that behind for a minute? Anybody have a different topic you want to discuss? How could I say that differently? You're like, I don't want to talk about it. Anybody have a topic they think would help them on the test if we talked about it right now? Is that a better way to put it? Yes?
So for the problem on the right side, is that the only way to write it out?
How do you mean? So you realize I had a problem up here that had the same equation that we would have gotten here, right? I didn't actually write the equation here. It's the same as what was over here. Is that cool? So how do you mean? The only way I could write this out?
Yeah.
Yeah.
Okay, I'll just.
What's the other option? Let me see, because I could be wrong.
That's all.
Or you just were hoping there's a different way?
Yeah, just
Okay.
this.
But I really want this to make sense. I mean, if there's a total of 58 people somewhere, and 8 of them liked the last season of Game of Thrones, how many of them didn't like it? There's 58 people, 8 of them liked the season 8. How many of them didn't like it?
50.
50. They're also known as rational people. Right. Okay, you guys semi with me? So it's the total minus this one equals the other one. That's how totals work. So normally we don't know shit. So if there are 58 people, and how many didn't like Game of Thrones? I don't know, X. And therefore, how many did like, or I don't remember which way I put it, didn't like it would be 58 minus X. 58 minus X is the rest. That happens so often in mathematics. We have a total, an unknown, so what's left? Total minus X. We see that all the damn time. Okay, I like it. So at this point, if I didn't put it on the test, you probably should slap. So it's almost definitely going to be on the test. This is a talk as a name of
The reason season
at least that one. And there's always got to be more.
The reason season 8 was so bad is so people read the book.
Oh, is that?
The book's already better,
I like
I hear, so.
He's in the back going, just read the book. It's better. Yeah. Yes.
You meant doing this, I forgot kind